The final thing that we're going to take a look at with this lesson is scientific notation. Now, what we looked at previously is base 10, and that's where we take every single place value and we multiply it by a power of 10. Scientific notation tries to simplify that a little bit and tries to make it so we just have to multiply by one base 10, but we deal with decimals then. And so we're going to take a look at how do we use scientific notation in solving for big and small numbers. Now again, when using base 10, each number which was being multiplied by a power of 10 had one decimal place moved over an equal number of spots as the exponent displayed. Base 10 uses only one number per multiplication statement, while scientific notation tends to simplify it by using all the numbers in one multiplication statement with a power of 10. Okay. So, scientific notation shows a number with only one place value to the left of the decimal. Okay, and so it's in the ones position, and the ones position is how that exponent is going to affect it, and all other values behind the decimal place. Okay, this value is then multiplied by a power of 10. And what that power of 10 is going to do is it's going to move the decimal place over, and it could add in trailing zeros or zeros in front, which will affect the way that that number is written. So let's write out these numbers using scientific notation. This right here, you'll notice, is in scientific notation. Instead of it just being one number, we have a decimal, 2.3. Now that's being multiplied by 10 to the power of 3, which is a power of 10 or something in base 10. But this is not just a single number. We've now added some decimals in there. What this does here is it moves our decimal place over. Okay, so our decimal place is originally there, and we're moving it over 3 spots. 1, 2, 3. Now, because this 3 is already in one of those spots, we only have to add 2 zeros, and so this number becomes 2,300. Okay, so instead of having to do 2 times 10 to the power 4, 2 times 10 to the power 3, and 3 times 10 to the power of 2, like we did with base 10, we now just do 2.3 times 10 to the power 3, and we move that decimal place over a little bit. Okay, this is good, and this may not be a simpler way of writing out a number like 2,300, like we see here, but once we get to a bigger number, like 10 to the power of 6 or a million, okay, it will definitely help out. The next one here, we'll notice we have some zeros in there, and that is by design here. Okay, so we have 4004 with a decimal place there, and we are moving that decimal place over 6 spots. Now it's positive, so we move it to the right. So it's 1, 2, 3, 4, 5, 6, and that's where our new decimal place is. Now the first 3 spots were already taken up by that 004 that we were given originally. So we only have to add in 3 more zeros at the end. And our number then is 4,004,000. Okay, that is our new number, or that is our number. That's what this represents. Okay, it's a large number which can be written out in a very simple way in mathematical form, or what we call scientific notation. Now we use it because it's called scientific notation as we use some really big numbers in science to represent really big things. And it's easier to write it out in something like scientific notation than it is in with a whole bunch of zeros or a whole bunch of numbers in behind. Now often they'll also round these a little bit to make it a little bit simpler, but we're not going to deal with that a whole lot right now. We can also do the same thing with negative exponents. So if we have 1.2 times 10 to the power of negative 4, we're going to write the 1.2 in here. And then we're going to move that decimal place over 4 spots to the left because it's negative. So it's going to move over 1, 2, 3, 4 right there. Now the 1 is already taking up that first spot, so we're going to put in 3 more zeros, and this becomes 0.123012. Okay, so it's 12 hundred thousands that it's dealing with. Okay, and that's because we have that extra 1 back there. Okay, just because, again, whatever we have behind this decimal place is going to stay back there. We just move the decimal place over 4 spots to the left in this case, and it's going to make a smaller decimal. Okay, the negative makes it into a smaller decimal. Let's look at one that really makes it in a small decimal. Okay, 5.93 times 10 to the negative 9. We do the 593 or 5.93, and now we move it over 9 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's our new one. And then we add in zeros into those spots. And we have an answer of 0.00000000593. A really small number, okay, which has a lot of zeros, which we don't have to write out if we put it into scientific notation. Now, another really handy thing is that on a calculator, you can't necessarily write in all of these zeros. Okay, depending on how many spaces your calculator has, most are limited to 9 or 10 spaces. That's about the maximum. You would not be able to write this whole number in, but we can actually use these on a scientific calculator, and I can show you how a little later on. It becomes more important once you get into grade 10, 11, and 12 when you're looking into sciences, especially when you're dealing with things that are really big and really small. Now finally, this is taking something in scientific notation and writing out in standard form. Let's take a number that's in standard form and write it in scientific notation. This first number right here, how we do that is take a look at the numbers that are given that are in front of or behind our zeros. So here you'll notice that these are all zeros, okay? And we're not going to worry about those numbers right there because they're all zeros. We're just going to take a look at this right here. 67 becomes 6.7. And what we've done is we've moved the decimal place from here 1, 2, 3, 4, 5, 6, 7, 8 spots. So then we multiply by 10 to the power of 8. Okay, and it actually does simplify things off, and it makes it a bit easier to recognize, okay, what does this number look like in a bit simpler form without a whole whack of zeros in behind it. Okay, the next one here, 23,125. Now what we're going to do is we're going to move the decimal place over 1, 2, 3, 4 spots. So it's going to be, sorry, we'll get to that in just a little bit. But the thing is with this one is that all the numbers are there. There's no zeros behind it. So it's going to be 2.3125 times 10 to the power of 4 because we had to move it over 4 spots. Now it's in the 10,000s range, so it's going to be to the power of 4, just like our previous chart that we looked at earlier with the base 10. 10 to the power of 4 is the same as 10,000, so this is in the 10,000 spot, so then we have to the power of 4. Lastly, our final example is something that's in the decimal places. So here we're going to have 4.81. We take our number, we ignore the zeros that are in front, but now this decimal was moved over 1, 2, 3 spots, so we're going to multiply by 10 to the negative 3. Our exponent always represents how many times that decimal has been moved over, and if it's negative, we're moving that decimal place over the opposite to the left. If it's positive, that decimal place has been moved over to the right. And when we write something in scientific notation, we have to recognize how many spots it gets moved over, and that becomes our exponent. Now, working on scientific notation as well as some just practical numbers in context, I'd like you to look at questions 6 through 11. Okay, that is the rest of your assignment, so you should have all 11 questions finished for this assignment in 3 parts. Please send those in once you are finished via Google Classroom.